right, guys, let's see if this works. So I want to do number 25 for you guys. So number 25, and so they give us, what do they give us? They give us e to the 1/2 x. So they go e to the 1/2 x, and so we're going to do e to the 1/2 x. And so when we do this, and they want it at 0, so they want the coefficient at 0, so that's a Maclaurin. So we're going to be dealing with that one. So we'll tackle A, because they want the first what? What do they want? They want the first 3 non-zeros and the general term, so we can tackle that. So here we go. So we want to do our first. So this is going to be f prime. This is going to be f double prime, f triple prime, and if we need to, the fourth one. I always put 4 down, but we'll go from there. So we're going to take the derivative of this here. So this is what we were talking about today in class. If I take the derivative, I'm going to get 1/2, and I'm going to get e to the 1/2 x. So that's going to be my piece there. Now my second one, we're going to have 1/2 times 1/2, so we're going to get 1/2 squared e to the 1/2 x. And then if I do the next one, I'm going to get 1/2 cubed e to the 1/2 x. That's the beauty about what we were talking about today in class. The beauty about the e, I think that's why they use it a lot, is because it's very consistent for you guys in that respect, and that you could find them pretty quickly. So we need it evaluated at 0. So if we evaluate it at 0, we're going to get the derivative, the nth derivative, which is this one, divided by 0 factorial. By definition, that's 1. So e 1/2 times 0 is going to be e to the 0, which by definition is 1. So there's that piece. So then my second one is going to be e to the 0, which is 1. So it's going to be 1/2, and then that's going to be over the factorial of 2 factorial. Okay? And then we're just going to work our way down, and we're going to get 1/2 squared over, I'm sorry, that's 1 factorial here, sorry. And that's 2 factorial. And then we're going to get 1/2 cubed over 3 factorial, because every time I plug in 0, the e to the x just becomes 1. So there's my first 3 terms. So when we write this, I'm working as 1 plus 1/2 here to the x. And then the next one is going to be 1/2 squared, 2 factorial, so that should be 1/8 plus 1/8 x squared. Okay, so as we work through that, we can find out that this is going to become 2 cubed. Let's go one more so we can finish it. So this is 1/8. So that's going to be, we'll just keep it as this. Let's write it this way. 1/2 cubed, 3 factorial. I probably should have done that. And we're going to be x to the 3rd. So there's our first 3 terms. Now remember, this is going to be, let me rewrite this, guys. So this is going to be 1/2 over 1 factorial. And this is going to be 1/2 squared over 2 factorial. It makes me see the patterns a little bit better. So then we've got this piece here. So what's our general term? Well, this is n equals 1, this is n equals 2, and this is n equals 3. So now we kind of clean it all up, and we can write it a couple of different ways, but I'm just going to say it's 1/2 to the nth power times x to the nth power over n factorial. That's my general term. That's my general term. Okay? So that's my general term for that one. You can probably write it a little bit differently, but that still works across the board. So there's my general term for my Taylor polynomial of e to the 1/2 x. So then when we look at b, what do they want here? When they look at b, they want us to take g of x. So they say g of x is equal to e to the x minus 1 over x. So let's kind of break that into two pieces here. So I can take this, oh, that should be x. I can take this and make it 1x. I'm going to times that by e to the x, subtract 1. So we can make this its own piece. So I can do a Taylor series on that right there. So if we do that, we got 0, we got 1, we got 2, we got 3. And so we have e to the x, e to the x, e to the x, e to the x. See what I mean? E to the x's are just beauties. So then that's my first piece. Now I've got e to the x at 0, because I'm not shifting it. This is not shifting anywhere here. Okay, so I've got e to the x at 0, so that one's 1. E to the x at 0 here is going to be 1 over 1 factorial. This one's going to be 1 over 2 factorial. And this one's going to be 1 over 3 factorial. So if I clean this up, I still have this. I got 1x. I have my piece here, which is going to be 1 plus 1x plus 1/2 x squared plus 1/3 x cubed. Okay, that's inside minus 1. So then this cleans up. When I distribute this across the board, this is going to become, these cancel, because I got 1 minus 1, because it's dot, dot, dot. So at the end, this is going to cancel out, 1 minus 1. So those are gone, and then 1x times x is going to be 1. 1x times 1/2 x squared is going to be 1/2 x. 1/2 x. This one's going to be 1/3 x squared, and then this next one would be not 1/3. This would be 1 factorial. Factorial. These are factorials, guys. Factorial. This would be 1 over 4 factorial x cubed. So we've got that piece right there. And so now when we look at this, let's kind of, what do they want here? Let me double check on the directions. They want, and the general term. So we've got our first 3 terms here, so let's look at the general term. So if this is n equals 1, let's see, this is n equals 1, this is n equals 2, and this is n equals 3. Let's see how we get here. So let's put it in terms of n. If I go 1 over n, I add 1 factorial, and this is going to be the same as x to the n factorial. Does that work for us? So I plug in 2. 2 plus 1 is 3 factorial, x to the n factorial. So this is my general term. Okay, so that's my general term. And I'm going to do all of these basic ones. I'm going to derive them out. I think that's going to be the trick to it. It's going to help me out. So I'll do like a power hour where I just do all the different ones and we'll just do like an hour video and we'll go from there, okay? So those are the general terms here of this one. Now on the third one, it asks us to prove something. It asks us to prove e to the x minus, nope. Asks us to find g prime of 1 from part B. I think I'm pretty close to the end here, so I'm going to go ahead and erase this. It's a little close for you guys. So I'm going to erase this. So this was B right here. So now C, we're going to take, that pen doesn't work that good anymore. We're going to take our e to the x minus 1 over x, and we want to apply the derivative of that. And so that derivative is going to be a quotient rule. So we're going to have x times e to the x minus our derivative of x, which is 1, times e to the x minus 1, all over x squared. So let's clean this up. So we get x e to the x minus e to the x plus 1 all over x squared. And so this is going to be g prime, and they want that at 1. So this is g, and they want g prime. So this is g prime. And so they wanted to evaluate it at 1. So if I plug in 1 here, I get 1 times e to the first power minus e to the first power. Those cancel. So I get 1 over 1, which is equal to 1. So g prime of 1 is equal to 1. So now, what do they want us to make it equal to? They want us to show that it is the same as, show that's the same as n equals to 1 to infinity over n times n plus 1 factorial. They want us to make sure these are equal to each other. So now remember what we talked about. We're doing this piece here, and then when we create a polynomial, a Taylor polynomial, what we're saying is that this piece here, this general term, its derivative will be equal to the derivative on the other side. So let's take this general term here. So let's find the derivative. Find the derivative of the general term. So the general term is 1. I'll ditch the 1, guys. X, oh my goodness. X to the n, right? N plus 1 factorial. Remember, the n plus 1 is just a number, so we don't have to worry about it. I was looking at the camera over there. We don't have to worry about it. So we just got to apply the power rule here. Let me erase some of this. So what's my derivative here? So my derivative of this is going to be n, x to the n minus 1 over, we don't care about the bottom, n plus 1 factorial. And we want that at g prime of 1. Well, if x is 1, if I plug 1 in right here, this becomes null and void. It will always be 1 no matter what happens. This will always be 1, so we don't care about that one anymore. So therefore, the derivative of the general term is n plus 1 factorial. Voila, those are the same thing. All right, so have a good time. We'll see you soon. Good luck.